Hey everyone, welcome back to another Fix It Scotty video, and we're going to be talking again about the EV converted Volkswagen Bus. And in this video we'll talk about a upgrade I made to the accessory battery, the 12-volt accessory battery. I went from a lead acid car starter battery to a new lithium pack, and I'm going to show you how I did that. On the last video, I also mentioned how I was having such problems with the DC to DC converter and how I fixed those problems. It's no longer blowing fuses, and it's still not blowing fuses, but I learned some stuff from the EV conversion community where you could have other problems with the DC converter, and I put a protection circuit in front of it that I'll show you exactly how to build that will prevent any other issues with the DC converter that might happen in the future. And then finally, we'll talk about some of the other upgrades or minor fixes I made in the last video that I mentioned were problems. And we'll talk about some of the car shows I went to, one being an EV car show and another Volkswagen car show, and how this car was received in those. So keep watching and let's talk about it. So this is another project that's going to be a future video. I inherited this 73 or 74 1800cc bus motor from the previous owner of my 78 bus. I'm not sure why he had this, but it's a nice motor. I'm trying to get it running so I can sell it for the most that I can. And notice that this battery right here that I'm using to test start it is the battery that used to be in my bus and used to run the 12-volt electric system. Now, the problem with a lead acid battery like this is it's not really designed well to just keep up kind of small DC loads for a long period of time. Like, for example, an electric car, you know, the controller, the MCU, maybe even my little backup camera mirror and things like that that have B positives that have to stay on all the time. And those loads can all weigh down these batteries. The other thing is this is a cheap lead acid battery that I bought at a Tractor Supply store. And I even noticed that it would lose, without being on a maintainer, which you can see I have it plugged in now, it would lose voltage just throughout the week, just sitting there, just by itself. And that doesn't seem to be much of a problem with the lithium pack that I have. So let me show you that. So in my engine compartment, here is the new battery here. It is a 12.8 50 amp hour lithium battery. That's actually a LFP or lithium iron phosphate, and it's considered a deep cycle battery replacement. Well, what does that mean? Well, deep cycle battery, typically used in marine or solar applications, are typically lead acid, and they're typically charged with dumb power sources. And what I mean by a dumb power source is like solar charge controllers or an alternator from a boat, or even the DC to DC converter. They are not smart in that they're not monitoring the battery's voltage, and they're not adjusting anything or using an algorithm to properly charge it to the most efficient way for that chemistry. All they're doing is putting out, like, you know, 13.5 or 13.8 or maybe even 14 volts, and, you know, the battery will take whatever it can get. So that's why lithium has not been used very much in that application, because you can potentially damage or overcharge your lithium cells. But in the case of these new deep cycle replacement batteries, it has a huge BMS that's capable of handling 50 amps of charging. So that's how it can handle these dumb power sources without, you know, overcharging the cells inside. Now, I'm not promoting this particular brand. There are much better brands out there. I bought this on Amazon for a fairly cheap price, and I may have to upgrade it in the future, but it was fairly cheap, and it did come with a onboard charger, and that charger I put in my DC command center where I used to have that lead acid battery maintainer, and it works just the same way. As I'm charging the main battery pack, this thing will come on and it will do smart charging of that little lithium 12-volt battery. All right, well, now let's talk about the change I made to the DC to DC converter. Like I said, no more fuses have been blown, and it's connected to the battery, and it seems to work fine. But I read online where people can have issues with the DC converter kind of flaking out or feeding back or maybe even having reduced life. And I was offered a very good protection circuit that goes on the input of it. So see that new box there, that black box, I didn't have a better place to put it, but that black box is now on the input wiring So the positive and negative going into the DC converter are going through that box, through some protection circuitry, and then into the input there. Let me explain what that is right now. Okay, so that DC to DC protection circuit was given to me by a fellow named EV Rick, who's an Australian, and here's his website. Now if you scroll down on the homepage of his website to a section called Protecting the DC to DC Converter, you'll see he's got a circuit diagram for this protection circuit. This circuit shows that you have the positive and negative, the main high voltage, wires going into the DC converter. On the positive side, it's going to go through a diode, then through an inductor coil, and then into the DC to DC converter. And you'll also notice that there's a tap off on the other side of the inductor coil going back to another diode as well. Okay, so even though there's three parts, there's two power diodes and an inductor, it's actually just two parts. The part number they have there, and I'll link it directly to the part in Mouser, so you don't have to worry about that. But that is a double diode on a mounting plate, and they're both in kind of a parallel arrangement. So that takes care of both diodes. And then the inductor is an actual circuit board mounted coil, but what I do is I flipped it upside down and I soldered wires onto the leads and then just cut them down to size. So it's in three part numbers, the diodes, the inductor from Mouser, and then I'll give you a link to the black box that I put it in. The way it works is that the first diode prevents the DC to DC converter from feeding voltage back to the high voltage system, which could prevent issues. Then the second diode is just there to prevent any back EMF from the coil. And so the coil will just remove any noise or spikes from the high voltage lines, which could prevent any damage to the DC to DC converter. So that is the circuit diagram, and let me show you now the way I implemented it in my little box there. So here's a shot of what that looks like inside the box. So from the right hand side, the high voltage positive from the battery goes through the gland nut and it hits that first screw. And that first screw there is that double diode set, and that is on the anode side of the first diode. And then the cathode side of the first diode is above that. So these diodes are going upward. And as you can see, both diodes are linked together on the cathode side, on that upper two screws. And then of course it goes into the inductor and then out of the inductor back to the anode side of that second diode. And it also taps off, and that's what goes out to the DC to DC converter. And of course my negative wire just simply goes all the way through, it just passes right through that box as well. So that is how I built the DC to DC protection circuit. Another upgrade I made was a circuit that allowed me to run the DC to DC converter without the battery and vice versa. Meaning when the car is turned on, the DC to DC converter takes over, but in some cases you may not want it to touch the battery. In other words, you want, when the car is on, the DC to DC converter to feed your main power distribution, your battery to shut off, and the opposite when you turn the car off. You want, obviously, the DC to DC converter shuts off, the battery takes over. If you wanted to do this type of thing, I did hook this up on my car. So what I did was I added this relay here. Now notice that relay is very much like a 12 volt standard relay, but a lot bigger, and it's just a big 250 amp capable relay. And it's a double pole relay, so it has a normally closed and a normally open, just like these do. And so the way I've done this is from my battery disconnect, I've got it going through the relay on the normally closed terminal here. So when it's off, the battery is connected all the way to my distribution block. When this relay is on, it simply reverts to this terminal that's empty. So in other words, when it's on, it just disengages the battery from the system. Okay, so what I did was I wired that to my ignition key fuse block. The idea is when I turn it to the accessory position, the DC to DC converter comes online, and then this disconnects the battery. The problem that I had, though, that it didn't initially work properly. The reason being is because if the DC to DC converter comes on at the exact same time that this comes on the accessory key, the DC converter takes about a half second to actually come online. And what would happen is the battery would disconnect itself before the DC converter came online, and then you'd be in a situation where then this thing shuts itself off and cycles over and over again. So we didn't want that. So I added this little guy right here. Now what this is a delay relay. It's a 12-volt delay relay. And so all I did was I wired that to the ignition block. So when the ignition turns on, the DC to DC converter and this thing get power at the exact same time. But this has a little trim pot on it. You can set it to 0 to 10 seconds, so it delays when it actually turns on. So I set this to, like, say 3 seconds. So the DC converter comes online, then 3 seconds later this thing turns the battery off. So that way the DC converter might touch the battery for a couple seconds, but not for long enough to really hurt the battery or pull a lot of current. Now the reason I had this is originally when I had my lead acid battery, I was concerned with my little 50 amp DC to DC converter that I used to have, because what I observed was, I think I mentioned last time, was when I did current measurements on the DC converter, when all the accessories on the car are on, the brake vacuum pump, the lights, the windshield wiper motor, all that stuff, it will only draw about 20 to 25 amps, maybe at the most, which that 50 amp DC converter was more than capable of handling. However, with the battery connected to it, the battery could consume another maybe 20 amps of power just for charging if it was a little bit low. Well, the problem with that is now you got 45 amps and you're at almost the top of your 50 amp capability of that DC converter. So I was running like this. But the problem again there was with the DC converter blowing fuses, obviously then it would drop out and I'd lose all power. So I was kind of going back and forth on this until I actually got the thing fixed. Well, with my new DC converter, that has a 72 to 80 some amp capable thing, and of course I upgraded the actual circuit breaker to have 80 amps on it. So it's more than capable of 80 amps, which is more than enough to handle any kind of battery charging and the rest of the car's electrical system. So for the moment now, I left these things in, but I pulled the fuse that powers this so that basically the battery never drops out. It always stays in. Okay, so those were the main big upgrades I made on both the battery and the DC converter to make sure I had a nice stable 12-volt accessory system on the car. If you recall in my last video, one other issue I had was that the tachometer that I implemented, and I'll give you the video up above me, but this thing was running at double time. The explanation I gave before I think is accurate, where the 4-cylinder coil actually does 2 pulses per revolution, not the 4 that I thought. So what I'm actually doing is by providing those 4 pulses, because of that exciter ring having those 4 steel set screws or ferrous set screws in it, it was giving me 4 pulses, which is more imitating a V8 engine. So if you have a universal tachometer like I did, the fix to that was simply reach around the back and there's a switch on the back of the tachometer, 4-cylinder, 6-cylinder, or 8-cylinder, and I just switched to the 8-cylinder and that worked. Now if you're using a stock tachometer and it doesn't have that universal switch on it to change the cylinder arrangement, the other thing you can do is go back to the exciter ring and take out 2 opposing set screws on that ring and replace them with either aluminum or maybe a stainless screw would work, but non-ferrous metal screws that will still hold the exciter ring in place, but the actual Hall effect sensor won't see them and it'll only see the 2 steel ones, and that would allow you to make it work with the 4-cylinder type tachometer. So another issue I mentioned was there was a lot of creaking and squeaking in this back end, and it was real noticeable because of the silent electric motor. So I was able to fix that. I went up under here and just basically tightened, ultimately I think it was my shock towers that weren't fully tightened down. And so now there's no more creaking, no more squeaking, so that has definitely helped out a lot there. Another thing that was causing a little bit of squeaking and creaking was the spare tire, and I don't know what the original spare tire mount should look like, but what I did was I took a ratchet strap and an old rubber steering coupler, and I fed it through there, and I just cranked it down so that the spare tire sits in there nice and tight, and that doesn't seem to squeak or rattle anymore as well. So pretty much now it's nice and quiet, and the only thing I hear is wind noise and a little bit of motor noise. I also had a problem where I couldn't drive in the rain. I've gone through like so many iterations of these wiper motors. The problem is they don't make a brand new wiper motor for these cars. You just have to either, I don't know, you just have to buy an old one. So I finally am on my 5th wiper motor for this thing. I'm an expert at replacing these now. In a previous video, I was showing you how I had one wiper motor that was completely dead. I replaced that with another wiper motor that I already had, but that turned out to be from a bug and it went the wrong direction. And that's what I ended up with that video. Well, okay, since then I found one on eBay, so that's my 3rd one. Got a new one on eBay, put it in, it was real weak. And so I got another one either on eBay or the Samba. It was a little bit better, but it still stuttered a little bit and it was a little bit weak. Finally, my buddy sent me one that he found in California, a brand new old stock OEM motor. It was actually bigger. Put that in. Finally, it's, you know, a new old stock motor is actually the final fix for it. Now the wipers move and they don't stutter or skip or stall or anything. The other thing I did was I replaced those crappy standard Bosch blades with these nicer Rain-X ones, the silicone blades, and they work a lot better. Now I can go out in the rain and not have to worry about my windshield wipers not working. And another upgrade I made is actually in the garage. I put this shelf in here, and this is to show off all of my awards. Well, of course, I don't have that many because I just got this car going. But as you can see, I've already gotten a couple even this summer. Now this one was a electric car show. This part of the National Electric Drive event weekend, and I went to a little car show and I got a little trophy for my conversion here. And finally, I won an award at the Classic Annual Volkswagen Car Show that's in my area. What's nice about that car show, unlike my previous British car shows I used to go to with my electric converted Triumph Spitfire, I never won awards with that Spitfire, and the reason being is because when I go to that car show, there'd be like, 20 other Spitfires in there, and usually the ones with the best restoration got the awards. But in these Volkswagen car show, there's so many different types of cars and all that, and they have different classifications, which means there's a lot smaller pool. Well, I still wouldn't have won the bay window because there's so many better bay window, especially camper bus restorations, but they've got this one called the Club Favorite, which is kind of just an award that they gave me because probably I'm new and I'm unique being the only electric conversion there. So that was pretty cool. So I finally got recognized. And, hopefully next year I'll be able to fill this shelf out. Well, that about wraps up this video. I hope you enjoyed that and learned a few things about batteries and DC converters here. I've got some videos coming up. I'm going to do some stuff on the bus. Like I mentioned before, I'm going to have a video getting this motor started and running. That'll be interesting. Again, the only reason I'm trying to do that is to get that to sell. So I'm almost done with that one. I started on the video of these drop spindles that I want to put in the bus and give the front end a little bit of a lowering, 2.5-inch lowering there, but they didn't work with my Girling calipers. So I'm going to have to, once I sell that engine, save up and get me the ATE calipers that go with that drop spindles. Not only will that solve my height problem, but it'll also solve my braking problem because those Girling calipers are absolute garbage. I can't stand them. They squeak. They're hard to adjust. They're just terrible. So I'm hoping those ATE calipers and those drop spindles both take care of my braking problems as well as the ride height problem. And I've got a bunch of other things I want to do both on the bus for both EV and handling upgrades. So those videos will be coming out soon. So make sure you subscribe to my channel to get more updates on that. And until next time, I'll talk to you later.